Hey everybody, it's me, Mr. Duclos, and we're back with another fractions lesson. Our objective today is to decompose fractions as a sum of unit fractions using tape diagrams. Let's jump right on in. So today we're going to take a little bit of a step back and we're going to really make sure that we understand fractions. So what we're going to do is we're going to decompose these fractions 5/6 and 7/8 in two different ways. First, we're going to make each one into a tape diagram, and then we're going to make it into a unit fraction. So the first one we'll do is 5/6, and we're going to draw it as a tape diagram. So I'm going to draw my tape diagram, and then the 6 is the denominator, and that's the total. So I need to make sure that I have 6 total boxes. 1, 2, 3, 4, 5, and 6. Now in a perfect world, they'd be a little closer to the same size, so maybe I'll clean it up a little bit here. I want it to be maybe something like that, and like that. It's a little better. 1, 2, 3, 4, 5, 6. So that represents our denominator. Then I'm going to color in the numerator, 5. 1, 2, 3, 4, 5. So now our tape diagram represents our fraction. And it's a good way for us to visualize it, because fractions can be a little hard to understand if we don't see it. And so right here we can really see it. We have our whole of 6 and our fraction, 5 of the 6, are shaded in. Let's do the same thing for 7/10. So we're going to do a tape diagram. So I'm going to draw my tape diagram. And then the denominator is the whole. So I'm going to make sure that I have 10 total parts. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then we need one more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then how many are we shading in? 7, the numerator. 7 out of 10. So 1, 2, 3, 4, 5, 6, and 7. So again, that gives us a good representation. It lets us really see it with our eyes. We have our whole with 10 parts to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the number that's shaded in is 7. 1, 2, 3, 4, 5, 6, 7. Now let's look at a different way that we can decompose, and we're going to use unit fractions. Unit fractions mean that you have 1, so 1 over the denominator. So we have 5/6. We have 5 over 6. So using unit fractions, it would be 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. So now we have 5 over 6 is equal to 1, 2, 3, 4, 5 unit fractions, 1/6. We can add it, 1, 2, 3, 4, 5. So it equals 5/6. Let's try that again over with 7/10. So again, we're looking at the denominator first, and we're figuring out that the unit fraction is going to be 1/10. 1 over 10. And how many times am I going to do that? 7 times. So plus 1 over 10 plus 1 over 10 plus 1 over 10, 1 over 10, 1 over 10, plus 1 over 10. Let's see if I got it. 1, 2, 3, 4, 5, 6, 7. So again, we've represented this fraction, 7/10, as unit fractions. 1, 2, 3, 4, 5, 6, 7. So that's going to equal 7 over 10. Let's look at 2 more problems where we're going to do this, look at one more method, and then look at a different kind of fraction. So here we're going to practice 2 more times using tape diagrams and unit fractions, but we're also going to see if we can find more ways to represent it than just unit fractions. We have 10/12, and then we have 1 1/4, which is equal to 5/4. This is called a compound fraction. It's when you have more than 1. So the numerator would be more than the denominator. It's called a compound fraction. So let's do our tape diagrams first. We have 10/12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I made it a little too big, so we'll take one off. And we have 12. And then we're going to color in our parts. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we're going to use unit fractions. So we have 12ths and we have 10 of them. So it's 1 over 12 plus 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 1 over 12, 1, 2, 3, 4, 5, 6, plus 1 over 12 plus 1 over 12 plus 1 over 12 plus 1 over 12. I just fit it in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we have it as unit fractions. 10/12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you can actually do it the unit fraction way, but it doesn't have to be only unit fractions. So I can see of another way to add up to 10/12. I can see 2 over 12 plus 2 over 12 plus 2 over 12 plus 2 over 12 plus 2 over 12. So if we count it out, 2, 4, 6, 8, 10. I used the idea of unit fractions, but I ramped it up. I made the numbers a little bit larger because that way I didn't have to write as much. Are there any other ways I could do it though? None as neat as this, but I could do 3 over 12 plus 3 over 12 plus 3 over 12 plus 1 over 12. So this time I got really tricky and I didn't make all of the numerators the same thing. 3 plus 3 is 6, plus 3 is 9, plus 1 is 10. 10 over 12. All of these are representing the same thing. They're all representing 10 over 12. Now let's move on to our compound fraction. So a compound fraction, I'll write it up on top. Compound. That's a fraction where our numerator is more than our denominator, or we have more than just the fraction. So in our example here, we have 4 total. So 1, 2, 1, 2, 3, 4. But then I have 5/4, or I have 4 over 4 and 1 more. So I'm going to color in my 4, and then I'm going to add 1 more and color it in, because that's my 1 left over, my 1/4. So now we can see it as a tape diagram. Now let's do it as a unit fraction. So what are we adding? We're adding fourths, and unit means 1/4. So we have 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4. 1, 2, 3, 4, 5, 5/4. Or 1, 2, 3, 4, which would equal 4 over 4, and then there's a 1/4. And 4 over 4, that's the same thing as 1. So it's 1 1/4. But are there any other ways that we could do this? Well, I don't see anything super even, like down here where I could go 2, 2, 2, 2, 2. But I do see another way that I could add to 5/4. I could do 3 over 4 plus 2 over 4. 3 plus 2 is 5. Now we're going to move on to one of your application problems. Then you're going to go finish on your own. So here I have the first problem for your independent work. It says, how many eighths are in 5/8? And it wants you to draw a tape diagram to find the answer out. So I'm going to draw my tape diagram. 1, 2, 3, 4, 5, 6, 7, giving me 1, 2, 3, 4, 5, 6, 7, 8. If you're drawing a tape diagram, always make sure at the end you do count how many are inside, because if you mess that up, the whole thing's not going to be good. So we know we have 8, and we're going to circle or count 5. 1, 2, 3, 4, 5. And now we can count how many eighths are in 5/8. 1, 2, 3, 4, 5. The other way you could do it, although this problem specifically asks for a tape diagram, would be the unit method, where we'd go 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. And then we count it up again. 1, 2, 3, 4, 5. We know that the answer is 5. That ends our lesson for today. Can't wait to see you next time. Go finish your work and have a great day. Goodbye.